to Char Talk. Now we'll officially start. Welcome to Char Talk. The Minnesota Biochar Initiative is pleased to host this once a month to provide knowledge of benefit to the whole community. But today we have a special guest, Kevin Bernard. Not Kevin Bernard, excuse me, Kevin Shepard. Kevin Bernard is one who brought him out here. But Kevin Shepard started in the construction industry over 12 years ago as a carpenter. He has been knows firsthand the challenges our industry faces, particularly when it comes to waste. That experience ignited his passion for finding innovative solutions to make construction more efficient, environmentally conscious, and forward-thinking. Since 2020, Kevin has been leading impactful projects through Beltertech, developing sustainable construction systems that turn waste into valuable materials. He is currently serving as the Director of Research Development in 2024. Kevin co-founded the Synthetic Aggregate Association, SAA, a 501c3 nonprofit focused on lobbying and advocating for the adoption of synthetic aggregates. Kevin is dedicated to forming strong partnerships, sharing knowledge, working closely with peers, competitors, and industry leaders to drive positive change. His mission is not only to only innovate, but also educate others in the importance of sustainable development and developing a circular economy in construction. Kevin, the floor is yours.
Hi guys, I'm just logging in my computer real quick. Sorry,
Okay.
I am super
All
late.
right. We will punt for just a moment here. But no, it's great to have you. And it's great to see all the people that are coming on. They're coming on here today. If you hadn't heard already, feel free to enter who you are, where you're coming from, and what organization you represent. If you would like to be on the mailing list for MNBI, Katie will be putting the MNBI or MNBI admin email in there, and email Katie and let her know you want to be on there, and we will receive an invitation every month. So with that, I will hand the mic and the screen over to Kevin.
Thanks again, Jim. Do you guys hear me well? Everybody see the screen? And
Yes.
let me put my camera on. All right. Thank you again, guys, and appreciate your patience for me. Today I'll be talking about aligning biochars with the association that Jim talking about, the Synthetic Aggregate Association, and including recycled materials in low carbon construction. So a little bit about me is I work for a company called Beltertech since 2019. I've been in product development, procurement supports, and marketing support mainly. We're a small company, and I kind of handle a big role of the company from all different aspects. We do commercialize low carbon materials. Some of the projects we have worked on are the Government Service Administration and basically in New York City, some of our products went on to. So 26 Federal Plaza under the IRA Act procurement. A lot of the stuff that I do is actually commercialize these products from lab to field and actually help them with their manufacturing and integration. So whatever feedstock's going in, how to process that, and what market is that material going to go in or benefit. Sometimes it's multiple markets. So when I was developing these products, a lot of industry folks would come to me with new emerging technologies, and I could only do so much by myself and with our company, Beltertech, right? Thank God for Jerry, Jerry Hughes. He's our CEO of Beltertech, but he's the co-founder of Synthetic Aggregate Association too. I approached him and I said, Jerry, maybe we should start lobbying and advocating for these materials. It seems like people have a lot of trust in us. We could establish testing, we could make performance benchmarks, and we could actually become the standardization of these materials. I felt like we had a lot of trust across biochars, glass, plastics, and even mineral-based materials. Other materials like PRI foams and EPS foams and gasification processes that have some TDI residues. So we cover a very broad part of it, and I'll talk about some of the companies that worked on biochar during this, but I'll also talk about some of the companies that are involved in SAW on the other stuff, on the other materials that I'm used to. So a lot of people ask me, like, how did you do this and why did you do it? To be honest, when I was a carpenter in New York City, I've seen a lot of materials get wasted. A lot of the jobs that I've been on were multiple times tearing down sheetrock, and I always wondered where did this sheetrock and this steel go. So I started looking into it, and then Jerry gave me the opportunity to move to Atlanta and actually build Belter Tech's facility. And when I seen expanded glass bead for the first time, I got really interested. And in 2019, I kind of came up with my mission of emerging recycled and carbon-based materials validated into the commercially viable market or product. It applied research, testing, and industry collaboration. Over the last probably year and a half, my words, my slogans have been close the loop together and let's bridge the gap between industry and academia. So why this matters now? Construction is one of the largest resources in the world for global emission, especially the concrete industry. But when you put it all together, all the construction, I think it's over 45% now. Obviously, we all know that cement production gives 8% of that global worldwide CO2. And owners, designers, regulatories, and are demanding low embodied carbon materials, kind of like from what I read about the Minnesota initiative, right? You guys want to build better. I seen yesterday that, the U.S. Green Build are advocating in Georgia for the first time, and there's more and more things of this happening. LEED version 5 point something and now has global warming potential data into it and required into LEED, and it's given buildings points back. And also biochars and synthetic aggregates they're scalable. We could scale them. They're good solutions. It's the circular economy. I think there's just a lot of research and a lot of technical data that we all have to figure out together as a whole. So the role of biochar in construction to me, it's carbon-rich material accelerated through pyrolysis. Traditionally, it was been used in agricultural and soil improvements. If you talk to some of the people I know, char has been used in for a long time, especially coal, and it's very similar to coal and or charcoal, I should say. But it's kind of the same methods, but now we advance those methods into learning how to store energy and mineralize stuff, right? It's increasing interest in the construction materials have been over about 10 years now, and people are coming up ways to put it into thermal composite systems, putting it into concrete and cements, making panels out of it. I'm sure there's other ways. I know graphene's becoming big. I know they're starting to suspend this stuff in liquids, and different types of additives are being created. I know they're being used in the PRI foam market to lower GWPs, and it is a very interesting material for the construction industry right now as we meet those benchmarks for global warming potential. And the potential roles in cement and concrete. Our industry of cement and concrete is it's a small world, I would say. When you get to it, everybody kind of meets each other and hears of the same names. The big players in the industry, I would say, are starting to look at this stuff and starting to lobby and actually create standards for it, which I'll talk about in a couple slides. So what we in that standards that are actually being made, this is how it's going to be defined in biochar and concrete, right? You have your supplementary cementitious material, which is a partial cement replacement, which gives you a lot of your data for your GWP. We are also looking into replacing sand in places like New York or urban dense cities. Sand is being harder and harder to get when people are having to make more and more sand or alternatives to sand. So biochar could be replacing sand in some applications with some different feedstocks. It could be a functional filler. So it doesn't quite have the reactivity as cement, doesn't quite have the potential to replace some with sand. A functional filler does void gaps, right? So as you can see in that picture, concrete, when you want to make concrete, you want to fill every gap in it to make it dense or etc. If you could fill it with a lightweight material, it's even better in my opinion. And honestly, the CO2 reduction. So if you have a cement replacement and it's carbon focused, I think you have a better product than if it's just a cement replacement to replace cement's GWP, if that makes any sense. But what it's being used in the industry for is to reduce the CO2 in the concrete mix. So my opinion on the challenges, I I think there's inconsistent product claims. I think the market messaging is being held up because of some of the stories being told, and I'm not pointing fingers, but sometimes it's a lot of snake oil trying to get carbon credits and things like that. Where in our industry, when structural components matter, that kind of ruins the reputation of it. Limited standards and testing framework. We can't scale without these standards. We need testing methods. We need standards of those testing methods for performance, and they're not quite there, even though they're being made. Prices vary widely across producers. So, in my experience, and I'm not going to ever name names, but I've been quoted anywhere from $200 a ton to $850 a ton to $2,000 a ton. If we want to impact the market, we kind of need to come together and make sure that our prices are kind of close, right? That's a big reason why a lot of people are turning their heads to it. Engineering guidance is still developing. All these materials, all these feedstocks, which I'll get into, there's a lot of engineering to it. We're engineering it to the application that it's being used for. We can't just do the same process and put it into building materials that are structural, right? It needs to kind of have a lot of engineering to it to keep it consistent, that materials could be used consistently. There's limited awareness of how that actually works and why we can't just take wood and burn it and put it into concrete. I shouldn't say burn it, but that's how I say paralyze if anybody hears me. And processing impact performance. So a lot of people don't realize how much the process really costs and how much it really takes to get to that engineering, which we will talk about here. But that's my concerns of what I see with the people that I've dealt with and the other people that have reached out to me. Okay, why the biochar materials differ and why that consistency matters and why the engineering matters a lot is the feedstock. Right now, the big to topic is rice husk. I know we mess with softwoods, hardwoods, contaminated woods, and municipal solid waste is coming out, and we have different type of agricultural waste from, different Brazilian peppers and all types of stuff that we've handled. The paralysis is different. You have fast paralysis, slow paralysis, gasification, all at different temperatures. It's being studied right now of how this actually works, but where there's no actual solution and actual guideline of how to paralyze this to be good for construction materials and low embodied carbon materials. Your particle size. From what I see, particle sizes are all over the place. And when you try to get to a certain particle size, which we'll talk about, it could ruin equipment. There has to be engineering, there has to be processing. The chemistries, the physical chemistry to this from stuff that we're testing is all over the place. It's different. It's sometimes you have high silicas, sometimes you don't, sometimes you have good reactivity, sometimes you could read high carbon, sometimes you read low carbon. So this is what is the concern, and I know everybody is aware of this, but we have to kind of come together and talk about this if we want to make it feasible for an industry like concrete. So processing pathways for construction application. A paralysis gasification, what I'm seeing is slow pyrolysis and fast pyrolysis are the best materials for this. Best controlled, best consistency that we've tested. The feedstock variability, we're kind of limiting the feedstock in the concrete industry to be high in silicas, high in carbon, or engineered almost like a geopolymer cement where a couple biochars are blended together. Um, Grinding and particle size control, that's a huge thing for the process. I think if people are figuring out what screen size and how to grind this without maintaining equipment and keeping that equipment durable for a long period of time, will impact the price. Keeping consistent particle size that isn't too fine, that isn't too expensive, and finding the balance between, moisture and performance really and particle size. Screening, you could pelletize this stuff and you could also densify it, right? So there's different applications and different processing to get to that particle size. And then you may even have potential treatments for the particle size and the surface modifications to this stuff. So I guess what I'm saying here is in order to get to the application of construction, there is a lot of we are researching to do. Um, how does synthetic aggregates support biochar in the construction industry is we have a lot of representation at on the ASTM biochar in concrete standard that's being developed. From my knowledge and from my experience, I think it is being developed a lot quicker in ASTM than your average. I think there's a huge push on it. I know Lori Tunsall from Colorado School of Mines is leading that, and some of the industry support that are a part of Sal Alta Beta 012 and solid carbon are a heavy advocator in that biochar standard, and they have experience, which we'll go talk about. Um, the advocacy for inclusion of carbon-based materials in non-structural applications in city specifications. So getting involved with construction specifiers to get involved and take it to the city where they could require using this in sidewalks, using this in blocks and stuff like that for certain government projects or city projects that they want to do. I think that's huge. I think what we're missing there is actually people understanding how to specify this stuff before it even has a standard is hard, but there is ways to specify it and actually go to the cities and get them to use this. But you need the data, right? And how do we get the data? Is collaborating with researchers. I know I skipped the point there, but we really do need to collaborate with the universities, collaborate with the industry, and collaborate with the corporations and small businesses. So what I mean by industry education across the AEC community is architecturals, engineers, and contractors. The engineers are the most important to get comfortable with materials like this, no matter the application you're using it. They're going to be signing off on these projects. Your architects are going to love the idea of going green and being green and using this material that has going to give you less carbon emissions. And the contractors are the ones that need to use it. And a lot of the times, when you're putting these materials together, you're not able to completely work with it. You need to figure out new ways, which is why specification is important to explain those new ways into it. So I think the industry is going in the right way, but I think we're all worried about the carbon credits and actually being introducing this to each other that we're not focused on the right people that will actually implement this into the industry. If I went up to I know a lot of architects and engineers, and if I put a poll out there, I don't think 20% of them would know how biochar is used in the building industry and how they could specify it or how they could design with it. And I think that's a huge thing that's being misguided here. So 012, I know I mentioned them, Julia Heighton and Lori Tunsall, and they have a great team over there, but they've been engineering biochars for the concrete industry, maintaining performance using different feedstocks, figuring out how that feedstock and what type of um, improvements you need for your mix designs. And they do a great job. They're hands-on. They're in the lab. They're messing with different materials, and they're learning also how to move it and sell it, right? So it's great to see a company like 012 a part of SA. I think a lot of you guys, if you're into the biochar, you would know about 012 and what they're doing, but I just want to give recognition to a couple companies that are a part of SA here. They're located in Colorado. So if you guys ever need anything, feel free to reach out and I could connect you. Solid carbon is also somebody who's engineering biochars to incorporate into concrete specifically. But they've led the way, I feel. This is my opinion, but they have field projects. John Mead was a carpenter or a builder in the past, so he has those connections, and he's done a great job. And the picture to the left is a winery that I actually got to visit myself when I went out to Oregon and see it, and it looks really cool. Something that I've always thought was really brilliant about biochar and concrete is that it does make the concrete darker. It could be black. It is nice. It's good aesthetics, honestly. I think a lot of people would like it. Ferris engineered wood up in Oregon as well. I didn't really understand how a cogeneration plant made char or made biochars as a byproduct until I went there and seen it. And it's a very cool operation that they actually supply power to 10,000 homes around them, and they do mass lumber. So they build really cool stuff, and they have this waste, and there's a lot of it that they're trying to get rid of right now. They're in the agricultural industry a lot, but they're trying to push their way into the construction industry by testing and modifying their process and how their char is produced right now. Well, not produced, but I guess delivered to the end client. ArborX is in Southwest Florida, like near Naples. ArborX has a machine called like the Char Boss, and they've got it up and running recently where they're taking clearing debris from land out there, different types of waste streams from Brazilian peppers to different type of agricultural products. They've done a great job recently working with carbon credits and getting into that system, talking to some of these data centers. I've noticed, but they are trying to get into actually creating a product for supplementary cementitious materials and sand replacements. So they're starting to really come a leader in the construction industry for biochar as well, or concrete, and looking into it at least. Kevin Bernard with Mobile Biochar Systems. Kevin does fast pyrolysis, and he has a very unique type of system that he could take. He can make a kiln pretty easily and bring it to you on mobily, right? In small scale operators to produce biochar and avoid their waste. Me and Kevin have been working together to try to figure out what type of materials he produces with fast pyrolysis I could take and introduce to the industry and see how that performance and how that data looks. Alta Biota is a Canadian company who has a liquid concrete admixture with biochar. It's suspended. And as you can see over here, they get that really black concrete that I like. So I think their product is, like I said, they're leading in the industry with the standard. Alex Hanmore over there is a very good technical writer, good for lobbying, good for getting this into standards. And I could see this company really doing a good job with this concrete additive in the future. It reduces cement and it has a lower embodied carbon than typical. Biological carbon was also out in Oregon. John Miedema is honestly one of my mentors, and he engineers biochars for all different applications, water treatment, soils. He looks into the arsenic that's in there. He looks into the phosphates. He is a real good mentor of mine and has taught me a lot of what I know. He's told me where the snake oil is. He's told me what the problem is with it, and I see him working daily to solve the problems of the biochar industry. And another reason why, when we started synthetic aggregates, we defined biochar into this is to support his research and the stuff that he does. Um, he's been doing some really cool projects all around. So if you guys, anybody ever wants to reach out to him, feel free if you have any questions about them to me as well. So probably like, well, geez, you guys do a lot of work with all these other companies. What is your end goal? So my goal was to, in 2023, I had this product Belter Yield EPD that would go into this federal project in New York, right? Our EPD and GWP was too high for the IRA Act standards, so I had to incorporate some other materials into there. I actually took a plastic aggregate from CRDC, and I replaced our natural aggregate into the bag, which lowered our GWP enough to get to the standard. Now I want to keep supporting that. In 2025, I was able to switch my cement out and reduce my GWP again. And now in 2026, this is the product we will be launching. It's Belter Yield EPD, but it will be using 012's Z12 product. And we've reduced our GWP by almost half. And once we start selling this product, so we've done great collaborating. In the Synthetic Aggregate Association, a lot of these biochar companies are working with each other, listening to each other's advice, and actually trying to explore different options together. So we're not taking it as competitive. We are actually trying to develop the market. And a lot of people will ask, well, how do we evaluate biochar into materials or into concrete? The first thing I like to take a look at, again, a lot of people will probably have different opinions, but I take a look at the reactivity with the University of Miami. There's a modified R3 method that they use that it could give me the calcium hydroxide consumption in 72 hours. And that pretty much shows the heat release, right? So in my little, oh, Jesus, in my little chart there, I show you ground glass furnace or slag, right? That it's around 450 joules, and on the fly ash side, we're at about 300 joules. You could see I label it Belter biochar so that there's nobody's data out there, but the biochars that have tested have been around the 100 joules part. That means we could replace around, 5 to 10% of cement. We are seeing more biochars test at the 2 to 300 range where you're able to get 20% to 30%. And there is people modifying biochars to get up to the 40 to 50% range. Personally, when I've tested, I haven't seen that yet, but there are claims out there that they're making, and you could see with the other biochars that have tested, there are some potential into it. We did this dot up here that does test above fly ash and in the fly ash range actually was a company where biological carbon, John and I had done slow pyrolysis to a municipal solid waste from grease traps, blended it with some minerals and some other stuff that I guess could be part of my IP if I ever was able to come up with a process. But we were able to engineer that material as a biochar to react just as much as fly ash. Um, but what was the problem with that material was the workability. So when we started actually looking at how it flows, looking at the slump, looking at how you could use a steel trowel against it, we noticed that, there was some issues there that it would actually narrow down your applications. We look at the performances, of course, the strength, the air percentage, the water demand. I'm only saying that because that's what we see the biochars affect. If you don't modify your mix design, your strengths aren't going to reach the appropriate benchmarks. You're always going to add a little bit of air unless there's some type of treatment you could use. And then your water demand is always going to go higher from what we're learning right now. Unless you want to use more plasticizer, which will reduce your water, right? But what mix design adjustments need to be made as the water is the amount of chemicals that we're using and the cement amount that we're using, the cement or sand. Durability considerations. A lot of people aren't really looking, well, a lot of the companies that are in our association are looking into it, but I don't see a lot of durability considerations around these materials. And however that's tested, I think we need to prove that when this material goes into concrete, that it will last the same as that old mix design that we are at. And I do see some issues in the field with this, so that's why I recognize it. Um, the challenges with the carbon-based materials is kind of what I was just kind of getting into, but the water demand, the air entrainment, the workability, and the consistency are a huge thing for engineering this right now. It's hard to balance those three when you're making these products, but I mean, it has been proved that it could be done. The economic factors, I hope you like my little alien in the corner there. But the processing cost, what is the ROI? What is the CapEx? I think have been a real struggle for some companies to figure out, especially in today's economy. Transportation, where is the material going to go to and how far? It really needs to, for it to work in construction, it really needs to stay in a 100-mile radius. I could say a lot of people will say 500-mile radius, but not when it comes to concrete. Concrete is kind of cheap. It's a low value product. We need to keep it low value in order to sell this stuff. So we really want to be looking for off takers and feedstock suppliers around that 100-mile radius of wherever we're processing this. Blending cost. You're gonna have to blend this stuff either before or after with some things, in my opinion. It's happening, and I think that's what we need to look at. And the cost actually at the blending plants as well, or batching plants, if they need to put any investment in to actually move this material. One of the big things I'm going to keep Henson on is the market pricing. I think that is a huge topic that needs to be talked about within the industry. I have never been in part of any of those conversations personally, but it is something that I see from the outside that I see as a huge issue. The claims on carbon credits and how carbon credits works, I know are a little iffy right now. And again, I'm not an expert on carbon credits, but I see that it's not possible for everybody to keep in the biochar industry. They're not getting the same price for a certain biochar, and it's kind of messing up with the market pricing as well. So the carbon credits definitely, I know Vera and Pure Earth do a great job, and a couple other guys, but I know it's out there. I don't know a lot about it. I know it impacts the economic, either good or bad. Handling and logistics. So these are concerns, but also price values that we're all kind of looking over, right? Storage, if it's that fine, what is the dust control like? When we're batching it or when we're putting it into a storage unit or a package, how does that work? It gets very messy very quick. And again, it could ruin some of the storage containers that we're using. Capability with existing systems. So the cement industry and the concrete industry, I know there's some disruptors and movers and shakers out there, but uh, they're dinosaurs. They don't always want to add in new silos or new methods to introduce to their current batching plants. It's a very hard thing to convince them to do, and we need to go there with options of not so complicated. I think that's the main thing. I don't think there has been any major proof of people moving biochar in a tanker truck or a rail car. Right now, it's being put into drums and super sacks, and that's not the best way to introduce this. It's not going to convince people to use it much. This and when we do get that specific equipment, and I know I mentioned this, but same thing with pneumatic trucks or blow-in trucks or rail cars. This all needs to be researched and looked at before, because if we're renting rail cars and we put biochar in it and there's a little bit of moisture, it could ruin that rail car from ever putting anything else into it, right? Or that pneumatic truck that we're going from a broker to, unless we buy our own trucks, which puts the price a lot higher. Again, this is the stuff that I see in the field, guys. I love the biochar. I am telling everybody the concerns of the things that I see in the field. What engineers need to see? They want to see test data. I know I said the engineer is the most important to raise awareness to for this product in the beginning, but once you say where's the testing, how is the performance benchmarks, what are we looking at here? What's the long-term durability? And what did you do? What test methods did you use? Whether it is for the road or the pavements, did you go to, NRMCA? Did you go through ACI? Did you go through ASTM? What ICC testing? What methods did you use? They want to understand all that. And that becomes expensive for these companies that are trying to develop biochar. A lot of the companies that are developing biochar have the feedstock to biochar, aren't in position to do $1 million worth of testing or $500,000 worth of testing to actually understand this product. And that's what the engineers are going to want to see. All right, so I'm coming up to I've been talking a lot, so I'm coming up towards the last of the slides, but I did want to go over some of the other companies' work that are within SAW and kind of just go through it real quick with you guys to show you the potential that's what is out there. Agriplex is a ground glass company. They actually make ground glass as it for an SCM, so they would be almost a competitor to biochars right now. Rebind makes fibers out of baling twine hay. So they actually take the ropes from the baling twine and they're actually able to make it into a applicable fiber for the concrete industry. local biochar, now mobile biochar with Kevin Bernard. Reboom America is a screening company that we've used for some of these aggregates. Agsco is up in Pennsylvania that could blend some of these materials together. Outside the box materials is making a unique cement replacement that's low embodied carbon, also looking into some of the biochar products. Climate Earth is a part of our association to tell us that these materials are low embodied carbon when we could, and they do help out of a lot of our climate clients. Uh, North American Composites, thermal composite system where, some of these materials actually thrive in those thermal composite systems rather than just concrete, cement, or mineral board making or some situation like that. CRDC Materials, Plastic Aggregate, University of Miami, does a lot of our testing, evaluates most of the materials that come through this association. McLanahan is a company that takes construction and demo debris waste and could come up with processing to recycle that into clean, valuable alternatives for products. Um,
What?
Solomon Color, Solomon Colors is a company that blends
Hey, just dropping off. Yes.
Solomon Colors is a company that has fibers that come from trees that are pretty cool. They're pulp fibers, EcoShell, walnut shells, Belter Tech. You heard a little bit about us. Amia makes some great minerals in the country and also looking into some of these recycled biochar products. You guys heard about Ferreris. EnviroCorp is a foamed glass company out of Canada. Eco Vante Garda, and they're from Paris, so I might have botched that up, but they're recycling gypsum paper, Admix Innovations into biochars. They're doing some graphene work. Eden Energy, a gasification company. Overlook Materials comes up with a lot of sand glass alternatives for water filtration and water remediation. Um, Ace Glass, another foam glass company. RED Materials has a broad index of materials, but their main material that stands out to us is the ground glass they have. Pathways complements our EPDs and our GWPs. Track Genesis, also another blockchain type of software company that are into looking at how this feedstock goes into a product. Solid Carbon, Artistic Pavers is a manufacturer from Miami that have used some of these biochars and ground glass and Hydro 360 materials into their pavers to get it done. Convestro is one of our biggest supporters. Want to see us grow and it introduced us to some gasification companies and has some experience there. CTL Group is a third-party test company that quantifies all these materials after we do our initial evaluation. And 012. 012 is the company that makes Z12 with biochar, right? Um, so I did a lot of talking and I wanted to give some time for questions. I did have a QR code here, but I don't know where it went. If anybody wants to reach out to me though, feel free. I could give anybody my email. Thank you guys.
Well, thank you very much, Kevin. Yeah, really appreciative, and it's great to see the participation of the audience here. We do have some questions that were in the chat here, and the first one is, are the IBI standards functional for the building industry?
I don't think so, not at the moment. Um, and my that's my just opinion. I think they get there. I think all this is getting there. But at the moment, I don't think there's any good standards.
And Kevin, just as an aside, you said so it's working with the Colorado School of Mines on the ATMs, ASTM standards. USBI did publish a ANSI-based standards for testing for North American standards that was recently accepted, and they're currently working on additional standards as well that might be more appropriate for North American industry. Uh,
Yeah, that
the uh,
sounds good.
the other question here, the next question, is there any potential reuse issues at the end of building or pavement end of life?
So they are looking into that, especially in the concrete industry. Some of our stuff is trying to accelerate the specimens that we make and grind those specimens back down so that we could see how it performs as a recycled concrete aggregate. That's some of the work that I've been looking at. Um, there has been other people who have looked into, so we personally actually look into a company that uses a carbon-based material into their foam products, and we're looking at how to reduce those, recycle those foam products back into an admixture for concrete. And we've had very good success with that. And it hasn't performed any different than their old product, and before they put this carbon black into it. So.
Oh, that's good to know. And the next question is for economics, it appears that mobile pyrolysis is the key. Is that what you think?
I think you're going to have a real hard time with DOT. I think Kevin has a good, very good option there because it's small. But yeah, I think mobile pyrolysis would be good, or a biochar depot type of idea where you have all this processing equipment in one standard location around the country, and that could have like 5 different locations, but like a biochar depot, somebody brings feedstock there, they could engineer the biochar at that biochar depot according to the application. That's what I think would be the best.
Fantastic. Getting back here. So where would the excuse me if I ask this right, where would the biochar be inserted in the cement mixture?
So like I kind of said in the beginning, it could replace cement, it could replace a portion of sand, or it will just perform as an additive for a filler. And by doing it any of those ways, you're going to reduce your CO2 if that biochar's GWP is low, which most of them claim to be negative, right? But we're close to negative.
Fantastic. All right. Biochar can be effectively transported. This is more of a comment. Biochar can be effectively transported in ship wagons. Moisture content is important. The next question is, are you familiar with the use of biochar in construction in Australia and New Zealand and also Europe?
Yeah, I think it's definitely more advanced out there. There's more applications, more people making it, less problems with the standards too. We move very slow in North America, I think, compared to the EN or Australia rules.
Fantastic. And for construction materials, which properties of biochar are more important?
For construction materials, I would say the silica content.
And there's another one here. Does anyone have any information about replacing coke with biochar in steel production? And Matt Arrow from NRRI, are you still on? Oh, yes, I see you. You're here. Is that one you'd like to answer?
Let's see here. Can you hear me?
Yep.
Yeah, there we go. I turned my camera on, but it doesn't. Oh, let's try that. There we go. Sorry about that. Yeah, so I'm at the Natural Resources Research Institute in Duluth, Minnesota, and we have a team that had done quite a bit of work on biocarbon as a an additive to the steelmaking process. And I am not really involved in that research directly. But if you want, if someone can contact me, I can put you in touch with the person who's leading that research because we do have a lot of performance data on that type of application, and we've looked at a lot of different species, both wood and agricultural materials as feedstock. If you want to either send me a chat message or whatever, I can put you in contact with the person that has more knowledge of that than I do.
And Martin, this is Jim Doughton. If you contact me or just send me a message through LinkedIn, I have a number of other connections of people working with steel or working with biochar and steel production as well.
Right.
But Matt should be able to help you out, he said, as a researcher.
Yeah.
So
That
Thank
will
you.
be
please let us know.
excellent. That will be excellent if you can give me some links or connections. That will be great.
Thank
Because
you.
steel is also a part of construction, a huge part, especially in the skyscrapers.
Mm-hmm. Yep. All right. Thanks.
Oh, those are really good points. And Martin from Berlin, I'm glad you're here.
Thank
But
you very much to invite me.
oh, it's great. And I believe that's the end of the questions that I have in here. And oh, yeah, I said here's one from Jackie. If silicon content is so important, has hemp been used at scale? Is it high? Is it high in silica content?
Yeah, hemp is being talked about a lot, and making hemp into biochar has been talked about a lot too. Personally, I've tested raw hemp before, and now I'm testing some modified hemps. So I don't have the right answer for you, but I think your assumption is right that it will do something good.
And then from Billy Van Kuren, biochar made with bamboo tends to have a higher silica content on the agricultural side.
Yeah, and it's done good in concrete. It still hasn't done anything past like 15% on the top of my head, and who've I worked with, cement replacement effectively.
Okay, and then Marshall Mermel has said, we have produced biochar for use in concrete that is stronger than reinforced concrete. We use Semtex to test the strength. If Semtex is the same thing as C4, that would be a pretty blowing up
Yeah.
your concrete.
Yeah.
I got to find out where you get your fireworks there, Marshall. But
Europe.
okay. And the final, or we have one here from Richard Ems. And again, Richard is with the Carbon Chicken Project. Very interesting project he has going down in central United States. What about poultry litter as biochar for cement?
This is also a new topic. This is also right now I know a couple people, researchers that are looking into this that aren't totally ready for their data to be published, but it is a topic.
Oh, fantastic. And do we have any hands raised for people in the audience who want to ask a question directly of Kevin? I don't see any. Okay. Says Alex England is mentioning, I have read some articles drawing attention to porosity as a driver for performance, potentially being no more or being more important than ash. Do you have an opinion on that?
Yeah, porosity has been a problem. And that's why they're doing some surface modifications on for surface area for the porosity performance.
And Cecilia in Kenya has a link in the chat here mentioning that Kenyan mixes are high in pozzolans and they get better MPA above 75 microns. And she put a link into the comment here. So just talking about Kenyan concrete.
Yeah.
So,
I believe it. Definitely.
well, these are some great comments, and it's good to see the participation with the folks around the world, particularly the folks around the world. It's great to see you here. I hope you come back for additional Char Talks. Drop us a line if you'd like to be put on the invitation list at the MNBI admin email link, and we'll be glad to have you on. We'll have some great conversations going here. And please join us next month. Who I said Susanna Lair will be talking about matching biochars and soils, and so that should be a good one. And we're trying to find some good speakers there for the upcoming series, and particularly from our international folks. It'd be great to hear some topics that are happening in your part of the world, so we can share the knowledge. Katie has just dropped in the membership information and the email address to ask about any questions going. Please keep in mind, this is MNBI. We're a 501c3 nonprofit, and it'd be great to have you on board. You don't have to be in Minnesota. But I really appreciate everybody being here today and
One quick
the
question.
participation. Yes.
So Kevin Shepard, quick question. So, in order for the adoption of biochar to be used in concrete at scale, as you said, it's got to be at the right price point and everything. But what are the quantities that have to be produced in your mind?
So if you were to use a natural pozzolan, I've done this with like zeolites when I first started, and this is why, I'm into the SCMs. I want to find an alternative to cement. But I had a client ask me, a big concrete client, for 200,000 tons a year. And I couldn't do that with zeolite. So I think that's the biggest challenge. That's why I think you need those biochar depots around these areas like Oregon, Minnesota, South Florida, or Georgia, Texas, where they control their DOT. I think it's going to really matter on the region that is specific and has the education in biochar to scale it. I don't think it will be somebody will ever be able to supply 200,000 tons of biochar in the next 10 years, to be quite honest, with what I see. But I have hope and optimism to that. But those are some of the numbers you hear. And the industry will tell you those numbers, and I'm disruptive, so they might not want to hear this from me, but um, they'll tell you those numbers to scare you off. They do. They'll want to know. They'll tell you those numbers to learn about your technology and kind of scare you off. And it might not be totally that. I think if you could produce anywhere from 50,000 tons a year, you're doing well, and you're going to save a lot of carbon.
So just as a comment, because I operate around the world, but specifically I'm the co-chair of Working Group 3 for the EU Cost Action on Biochar. In all of Europe, that's the 27 EU nations combined, along with all the Scandinavian countries, the amount of biochar produced in 2025 was 60,000 metric tons.
Yeah. And
that's a drip in the bucket. The good news is there is new technology, not new technology. It's actually pyrolysis is old technology. It's 80 years old. But there's technology out there that we're developing where you can actually produce 200,000 metric tons of biochar in a year or less.
Yeah, I put some feelers out there with some of the manufacturers I know, and they told me they think they could do it too. So I mean, it's probably possible. I think it's a long time to get there. I know those numbers, right? What you were saying, I think in America, it's something similar where we're not using half of it.
Right.
But out of 60,000 tons, you got to think about it. Only probably a quarter of that is real good for our construction industry.
Well,
Maybe in Europe, it'd be better.
In Europe, most of that was used. Most of that was used in Scandinavia, by the way, the 60,000 metric tons.
Okay.
You're right. A lot of it was used for some like soil amendment. There's hundreds of thousands of uses of biochar, but the big use in Scandinavia was paving and construction. And I can get you more information on that if you're interested. And we should hook up anyway because the scalability is really the big issue, and there is scalability available now.
Yeah, definitely. There's a couple of people in the chat I definitely want to reach out to too. So this has been a great opportunity. I'm willing to talk to anybody on the side. I was very honest today.
Great presentation.
I want people to understand the concerns. I could have done better on the presentation, but I do
Oh, you did a great
want
job.
people to understand the concerns that we have. And like I said, I have a pretty good hold here in North America on what we're doing in the concrete and construction industry of it. And feel free to reach out.
I just put my LinkedIn there, so feel free.
Can
More than
I
happy.
And we have Martin is doing
just
old
a
school
very
raise
quick
hand.
question?
Yes.
Because it's to me, I launched a huge project. It's a development of mine with a lot of modules, and my idea was using fast-growing plants to produce biochar. And have you any knowledge about using Kiri Paulonia trees as biochar in construction? Because I want to build geodomes out of Paulonia wood because it's the fastest tree growing on the planet. It's about 4 to 5 meters per year, and after 3 years you can get them to build houses and also biochar using because of the huge biomass it produces. Have you any idea of that?
So I think, yeah, it could be used. I think it will need to be blended with some type of reactive mineral or, treated some way. to get to the reaction for that application. That makes sense. But yeah, I think any wood could be used. It's just going to need to be blended and engineered a little bit. I truly believe that.
He's
Yeah, I
absolutely
think
right.
it's
Yeah.
always good to have a mixture of different kinds because then you have different minerals as well in it.
Yeah. Yep. Yeah, that's what you want. You want a variety of stuff.
Yeah,
The wood waste isn't going to give you everything, so we need to engineer it. You know,
yeah.
even the agricultural waste that is high in silicas, I still think we need to engineer a little bit better. You know.
There's a lot of straw and husks all around the planet. It's hundred thousands of tons, especially in India and everywhere. And in India, it will be good to have mobile biochar for the straw after the harvest and the husks. I know in Japan they use rice husk biochar as insulation material for roofs and for walls.
Yep.
Well, these
Yeah,
are
it's definitely possible.
some fantastic connections. And Martin, I hope you get a hold of Kevin so you can talk more about the
Yep,
European concrete.
that will be great.
And we have, like I said, we're kind of at the end of time here, and it's being respectful of people's times, but great conversations, great presentation. We really appreciate it. We record these. They will be available in about 2 weeks on the MNBI website through YouTube, and I'll be making announcements of that to let you know that it's going to be here because I've had over 200 people express interest in this topic, and a lot of the people are outside of the time zone where it's convenient. So it's a great, very topical information. Thank you very much, Richard or Kevin, for presenting this, and Kevin Bernard for bringing Kevin to the table. So
Kevin
we
didn't
really
mention
appreciate
much
it.
about the Synthetic Ag Association, but I recommend that people join if they want to stay fresh in the industry. Kevin does a great job running the association as well.
Yeah, definitely. Definitely, guys, feel free to reach out to me. I would love to have you guys and just get on a call and it's open for the public. So,
That's fantastic. We'll have to check that out. And a Synthetic Aggregates Association. So SAA.
SAA.
Okay. I'm glad my spelling works out. But I really want to thank you all today for being here. This has been a great discussion. If you want to be on Char Talk, and a lot of you out here have some great information, please get a hold of us. We'd love to hear what you have to say in presenting this to advance biochar across the industry. Thank you very much for being here, and have a wonderful weekend.
Thanks, Tim. Have a good day, everybody.
Yeah, thank you. Bye-bye.
Good job.